Hey guys, for those of you who missed today, what you missed was a little labby thing where we hung something on a spring, changed the mass, measured the different displacement, and we got a spring constant for 3 different springs. Now, ignore any data that you took in class. You're going to use the data that Mr. Ayers has already posted that will be linked to in the post for this. What you'll need to do past that, though, that's different from Mr. Ayers' class, is write a procedure. You're going to need to write how we get all the data that we get, how we know what we're doing. Now, first thing you're going to do, if you're going to be hanging masses on here, you need to know how much each of those masses are. Now, we kind of cheated in class and used 13 grams and for everything. Don't do that for this. You're going to need to actually weigh all of these. Do that. Mr. Ayers has posted the data. But that is a process. There's a step in measuring each of those things. Be sure to include that in your procedure. Then, once you've done that, you can set that off to the side. We needed to measure how long this displacement is. Now, there's a few different ways to do this. The way I like best, I'm going to measure right here, and I'm going to say that that is at a certain value. For me, it's 39 centimeters. I hang something on there, and I watch that it stretched out. Now, and I'm still measuring from the bottom of the spring, mind you, once it stops moving. Now my value is 26. So I had a change of 13 centimeters. So that change of 13 centimeters is going to be my displacement once I convert it into meters, of course. I can calculate the mass of this because I measured the mass of the parts. That's definitely a step to include. And then past that, I need to talk about what this mass actually does. This mass has a certain force of gravity on it. When I hang that force of gravity on here, it stretches out the spring. Well, when you stretch a spring, it pulls back. So the force of gravity pulls the spring down. The spring force pulls it back up. And when the thing is just hanging there, when I'm measuring it, so right there, it's in equilibrium right now. The force of gravity pulling it down is the same as the spring force pulling it back up. So we can use that force of gravity that we calculated. So we find the mass, then we calculate the force of gravity. That is equal to the spring force, the same thing. Make sure you include that. Talk about the physics in your procedure. You need to talk about how you get each number. Talk about why you know that each number is correct, and then use that as justification for every step along the way. Once you get all that data, which you're just copying from Mr. Ayers' spreadsheet, you'll need to make a graph of one of the sets. So pick whichever spring you want, make a graph of that set, and then calculate the slope of that line. That's going to be your spring constant. Everything I just said about making the graph of x on the x-axis and force on the y-axis, calculating the slope as that's the spring constant, all of that needs to be in your procedure. Include basically every single thing you have to do from sitting down at the lab table to getting a final value for K. That's what's going to be in your procedure. That's about all I got. If you have any questions, come see me in tutorials.